Okay, so inverse cosine functions just the same as inverse sine. What we have to do again is cut the cosine. And so the approved cutting location, leave that in red, is from 0 to pi. So we cut all that off, and now we just focus on this region only. And so our cosine is now 1 to 1 from 0 to pi. So from 0 to pi, it's 1 to 1. So that region corresponds to these two. So from 0 to pi. So these are now the positive. And so we're going to circle all of the x-coordinates because that's what we focus on. Oops, let's try that again. Got to do a little switch over here, right there to here, like that, and then back. Cut that guy right there. There. All right. So remember, cosine is the x. Remember, we have cosine x, comma, sine y when we're doing these for our unit circle. So these are now our x-coordinates. And so anything you plug into an inverse, you can plug any of these ratios into an inverse. But if you plug in negative rad 3 over 2, it's not going to give you 7 pi over 6. Negative rad 3 over 2 would be 5 pi over 6. So these are the values we get, the angles we get for negative ratios, and then these are the angles we get for the positive. And then that one's for 0. All right, so same idea before. We have from 0 to pi, and then it goes from negative 1 to 1. So now if we switch that for the inverse, it's now negative 1 to 1 and 0 to pi. So same rules apply here. If we're going to plug in x into our cosine, we need to make sure that it's between 0 and pi if we want to make that x stay the same. Doesn't mean we can't plug anything we want into cosine because its domain is all real numbers. But if we want to keep the 1-to-1 rules, it's got to be from 0 to pi. And then same thing for cosine inverse, it has to be from negative 1 to 1. That's just a standard rule because we already know that cosine will not go above 1 or below negative 1. So that just has to happen. All right, so let's try some. Inverse cosine of 2. Well, if we look at our inverse cosine of 2, go find it. Yeah, there's no x value of 2. We're not going to go above. So remember, the inputs here are the range of our cosine function. And that range of our cosine function cannot be above negative 1 or 1. This is a DNE. And if you check it in your calculator, it'll say the same thing. Now, cosine inverse of 0.2. Well, there's no exact value of 0.2 here. So what do? Well, you pull out your calculator and you find it. But we do know that this is positive. So we know it's going to be in this range here because it's positive. So if we go second inverse cosine of 0.2, we go to our mode, and I like everything in radians, but you can do degrees as well. So remember, this is spitting out the angle. So it's going to spit out that in radians. So 1.37 radians. Or if you want it in degrees, you hit mode, and then we change it to degrees. And then we calculate it again. And so it's 78.46 degrees. We'll do 78.5 degrees. So it's your choice on what you want the output to be. So if you remember, the inputs are actually the ratios now. The outputs of your inverse are the angles. With cosine functions, we input angles, it spits out ratios. Inverse, we input ratios, and it spits out angles. All right, so let's try this again. Cosine inverse of 2. Well, we focus on the cosine inverse of 2, and again, that is a DNE, so not good. All right. How about cosine inverse of rad 2 over 2? So this is where we use our unit circle because we know that is a good value. So rad 2 over 2 will give us pi over 4 or 45 degrees. I'm going to use pi over 4. And then we go back to cosine of pi over 4, and it says rad 2 over 2. So that's our rule that we had before. So as long as you input something from negative 1 to 1 into this function, it's just going to spit it right back out. So we could have just said, oh, that's rad 2 over 2 because of that. All right, let's try a 60 degree now. So cosine of 60, go back up. Cosine of 60 would be a half. So again, this is an angle. And this is our ratio. And now we go back up to inverse cosine of a half. So we have to look in here. So there's our half, and it gives us pi over 3. So that was our rule before. So as long as we keep it between 0 and pi, and 60 degrees is between 0 and pi. It's between 0 and 180. So you can always change that as well. Just two different angles. We're going to get the same thing. So we really should go back and not say pi over 3, but we should say 60 degrees just to keep it correct. They're both correct, though. All right, cosine of 300. So we go up, and we find 300. So cosine of 300 would be a half right there. Cosine inverse of a half would give us 60 degrees, or pi over 3. So it's 60 degrees. So this is why this one fails. For this rule anyways. It's not between 0 and 180, it's outside of it. So what it does is when you plug it into cosine, it converts it into the ratio, but inverses will only spit out the ratios for these regions. So it just basically took the 300 and said, I'm sorry, we got to make it to half now. So it's 60. All right, inverse cosine of 0.5. So they will try to trick you every now and then. And you have to write it as a half. And so that would now be 60 degrees. It's the same answer as before. And there you have it. So sine and cosine, very similar. You just have to know the regions. So sine will be here and here, cosine's here and here. And if you forget them, you have this beautiful calculator that will tell you stuff. So watch. If I do inverse cosine of negative 0.2, you can see it says 101 degrees. That's this quadrant. And if I do inverse cosine of 0.2, you can see it's in the positive. And we already know they're all going to be positive in quadrant 1 because it's the best quadrant. And then the negatives are here. And if we do sine, watch, inverse sine of a negative, and you'll see what it spits out. See, it says negative, so that's in quadrant 3. So this is sine, these two. These are cosine.